AI is changing everything, from how businesses make decisions to how machines understand language and images. But here's the truth nobody talks about. AI can't work without data mining. It's the process of digging through raw data to find the patterns that make AI smart. This video course is Introductory Data Mining. The book the material comes from is Data Rookies, Data Mining Basics, available from Data Analytics Curriculum LLC and can be direct downloaded from the website. In addition, there are supplements and lab exercises for download. Chapter 3: Data Preprocessing. Data preprocessing. Essential step to prepare data for mining. Involves data wrangling, cleaning, modifying, restructuring. Data preprocessing is the second of the 5 major steps in data mining. Welcome to Lesson 3-1, Cleaning. In this section, we'll explore one of the most important steps in any data analytics project, making sure your data is clean, accurate, and ready for analysis. By the end of this lesson, you'll be able to define what data cleaning is and explain why it's essential. Identify and fix common data issues such as tight mismatches and out-of-range values. Distinguish between missing and incomplete data. Recognize and correct errors in text, patterns, and field alignment. And finally, prepare a dataset that's truly ready for analysis. So, what exactly is data cleaning? Data cleaning is the process of correcting discrepancies in your data. Before you can trust your analysis, you need to make sure the data itself is accurate and consistent. Think of it as proofreading your dataset, catching typos, formatting errors, or illogical values that could lead to wrong conclusions later. Let's look at some of the most common problems. The first is data type inconsistency. For example, imagine a column meant for ages, but some entries are numbers like 25 and others are text like 25. Mixing data types confuses your software and leads to calculation errors. Always make sure each column has one consistent data type. Next are data range problems. Sometimes a value might technically be the right type, but not realistic. For instance, a birth year listed as *2300* instead of 2003. These kinds of out-of-range errors can quietly skew your results unless you check for them early. Another common issue is data uniqueness. If each record should represent one person or one transaction, you don't want duplicates. Using unique IDs helps you detect and remove repeat entries. Then there are spelling and capitalization errors. For example, New York, and New York might all appear as separate categories. Standardizing capitalization and spelling helps maintain consistency across your dataset. Next, set membership. Some fields, like college year, should only contain specific values: freshman, sophomore, junior, or senior. If you find frosh or fifth year, those should be corrected or categorized properly. We also see pattern issues, like inconsistent phone number or zip code formats. For example, some entries might have parentheses, others dashes, or even missing digits. Creating a standard pattern across all entries makes your data much easier to process. Cross-field issues happen when values in related fields don't make sense together, like someone listed as age 5 but with a birth year of 1980. It's a sign that at least one of those values is wrong. Then we have missing data. This is when information simply wasn't recorded, maybe a survey question left blank or a sensor that failed to capture a reading. Missing data can be random or systematic, and both require careful handling before analysis. Incomplete data is slightly different. It's when part of a record is filled in, but key details are missing. For example, an address that has a city and zip code, but no state. That makes the data less useful and can lead to confusion during analysis. Finally, watch for random characters or extra spaces. Something as small as a trailing space after a word can cause your software to treat two otherwise identical values as different. Always trim white space and remove stray symbols before moving on. In the end, data cleaning is about ensuring accuracy, consistency, and reliability. It's what turns raw, messy information into a trustworthy foundation for insight. Without clean data, even the most advanced analysis or visualization will produce misleading results. So remember, good analysis begins with good data hygiene. Taking time to clean your data saves time and mistakes later on. That wraps up Lesson 3-1 on data cleaning. Remember, the book and supplemental resources are available online at Data Analytics Curriculum's website.